Hello everyone, welcome to the problem discussion video. So today's problem is on the topic of relative velocity. In this problem, particle B is moving towards right with velocity of 3 meter per second and the particle A is vertically at the down position. It is moving towards B with velocity 4 meter per second. We have to find out the minimum separation between A and B if the initial separation between them is 10 meter. Let's see how to solve this problem. You can use the concept of relative velocity here and you can solve this problem. You can think that what is velocity of particle B with respect to particle A, or either way you can find out velocity of particle A with respect to particle B also. Anything you can do. That means what is the actual meaning of this velocity of particle B with respect to particle A? That means if we keep A fixed at some point, how it will observe either another particle is moving. That is the concept of that. Similarly, if we want to find out velocity of particle A with respect to particle B, that means how B will observe A to be moving. Okay, so for that we need to draw the vector diagram. Let us draw the two velocity vectors. So from here we'll try to draw it. VV is directly towards right direction. So this is VB vector 3 meter per second. And what is BA? Upward. They're making 90-degree angle. 4 meter per second. BA 4 meter per second. That means let's take this one. VA with respect to B. What is VA with respect to B? Velocity of A minus velocity of B. That means whoever is observing, we have to subtract that velocity from the another particle's velocity. So here B is right now observing that. That means we have to subtract BB. Subtraction in vector means you have to just reverse the direction of the vector. That means it's 3. Now what is the resultant? This direction. That is the VA with respect to B vector. Now see, we can shift this vector here also. 3. If the height is 3, the base is 3, we can find out the hypotenuse. What is the value of this hypotenuse? 5 meter per second. In this triangle, this 3, this is 4, so this is 5. And what is this angle? Tan inverse. This angle, if it is theta, then tan theta you can do 3 by 4. Tan theta equal to 3 by 4. That is 3 by 4. So theta is basically equal to tan inverse of 3 by 4, that is 37 degree. Okay. Now let us come to the picture of the problem. VB will keep fixing here. If we take VAB, that means particle B is observing particle A. Right now we'll fix particle B. How particle A is moving? In this direction of the vector. This is the vector direction where particle A is moving with respect to particle B. So A is moving like this. This angle you know from the vector diagram, that is 37 degree. Now you think about this incident. Suppose you are fixed here, you are standing here, and somebody is moving along this path. What will be the minimum separation between you and him? When another man or another particle is traveling in this path, when he will be traveling here, that means you have to draw one perpendicular to his path. Then this distance is the minimum separation between them. So we can form one triangle where this angle is 37 degree. This is initial separation 10 meter. Now from this triangle, this right angle triangle, you can find out what is this one. This is 10 sine 37. 10 sine 37. This minimum separation. So that is 10 sine 37. That is 10 into 3 by 5. That is 6 meter. 6 meter is the minimum separation between A and B.